Lami's theorem. What this Lami's theorem talks about is, suppose if three vectors forms an equilibrium, then the sign rule applies for those three vectors. That's essentially the summary of this Lami's theorem. So, if three coplanar vectors, the sign of the angle, then each is proportional to the sign of the angle between the other two. Other two vectors. So this is the essential thing. So here actually, suppose if three vectors forms an equilibrium, let us say this is a body, and this body, let us say there is one vector in this manner and there is one more vector in this manner, and then there is one more vector which is exactly opposite in this manner. Now actually all the three vectors together, if it keeps the body under equilibrium condition, which essentially means that the resultant of all the three vectors together is equal to 0. Now this can even be represented with the help of the triangle. So here actually, suppose if I draw this vector, this is the horizontal vector, and then actually this vector, so this vector if I put it here, this is the vector, and then actually this vector. See this, all the three vectors together actually it forms an equilibrium, or it forms a triangle. If it forms a triangle, we know that the body is under equilibrium condition for this particular set of forces. Now here actually, if it forms three different vectors, so same thing actually if I try to represent at the concentrated point here. So here actually if you notice, this is one vector and this is one vector and this is one vector. Now this is a free body diagram. Now the angle, suppose this vector if I take it, this vector is proportional to the sign of the angle between the other two. This is the essential means of this Lami's theorem. Now this vector if I take it, this vector is proportional to the angle between the sign of the angle between the other two vectors. Same is the case. This vector is proportional to the sign of the angle between the other two. So this is what is the Lami's theorem. Got it? So if it proportional to the sign of the angle between the other two vectors, if that is the case for all the three vectors, then as per Lami's theorem, the body is under equilibrium condition, or these three set of forces will form an equilibrium, provided if any vector if I take it, that vector should be proportional to the sign of the angle between the other two. Got it? Now let us prove that one. So if the body is under equilibrium, then P plus Q plus R should be equal to 0. This is the condition for the equilibrium. So if all the three forces together it makes an equilibrium, then the sum of the three vectors should be equal to 0. Then if I take any cross product, so with P, let us say, so P cross P plus Q plus R, P cross 0. Now here actually P cross P plus P cross Q plus P cross R is equal to 0. And P cross P is anyway 0 because it is the same vector. And then if I take it P cross R, then this is equal to, if I take R to the other side, minus of P cross Q, or this can be written as P cross R is equal to Q cross P. This is one condition. The same thing if you apply with Q. Q cross P plus Q plus R. Q cross 0. So this is Q cross P plus Q cross Q plus Q cross R is equal to 0. So Q cross Q is anyway 0, and then Q cross P plus Q cross R is equal to 0, or Q cross P is equal to minus Q cross R, or this is equal to R cross Q, Q cross P. So P cross R, P cross R is equal to Q cross P is equal to R cross Q. So here actually these three vectors are equivalent. If I put it the angles and then the magnitude, then PR sine of angle between P and R is equal to QP into the sine of angle between Q and P is equal to RQ into sine of angle between R and Q. Now these are equal. Now if I divide the entire thing with PQR, now this RQ and this RQ will cancel, this QP and this QP will cancel, and this PR and this PR will be cancelled, and then so here actually sine of angle between P and R by Q is equal to sine of angle between Q and P divided by R is equal to sine of angle between R and Q divided by P. So this is Lami's theorem. See this? Now the denominator, whatever the vector, see this is the vector Q, and the angle that needs to be considered is between angle P and R. This is R, and the angle that needs to be considered is angle between Q and P. Similarly, if you take P, then the angle that needs to be considered is R and Q. So leaving this vector, the other two vectors angle we should consider. So this is what is the Lami's theorem. And the main application of this Lami's theorem is, if the body is under equilibrium condition, you will be able to identify the unknown force. So you know that actually two different vectors you know, and then you know that the body is under equilibrium condition. So then actually with the help of these geometrical angles, you will be able to identify the unknown force magnitude. So he says that it is proportional, which essentially means that all these ratios are constant, or all these ratios are equal, then this can even be equated to a constant K. So here sine of angle between P and R is equal to KQR. Sine of angle between P and R is proportional to Q. This is how you can write it. The same thing you can write for all other three. Got it? So this is the Lami's theorem, which will be useful in identifying the unknown force magnitude.